It's a ball pen refill, and you put a card sheet or stick a card sheet. There is a parrot on one side, there is a cage on the other, right? And with your hands you can see the parrot inside the cage, right? And now there is a bow and the arrow. With the two broomsticks you can make a bow. Old sketch pen. Old sketch pen. Now you take the refill out. With the refill, remove the thread. You can see the arrow is towards you, and I'm going to rotate it by half a turn. Can you see a cross in the thread? A cross in the thread. And push it inside. And what do you see right now? Parrot. Now cage. Now parrot. Now cage. A very nice machine. A bird in the cage. And you can make a very nice mixing machine. Mix curds and make buttermilk. Right? This is just card paper. You can see this is doubled. Body and the head are 2 layers, doubled. So in this you put the shoulder. And needle thread, 1 knot, pull out the needle, another knot. All these are thread knots. And this is a broomstick. And now you just see. Right? And if I spin it like this, it's like the flying man. Very simple toys to make. You can go back and you all can make all these toys. Right? This is the simplest. One broomstick, long, short, and you tie them with a thread. This is not at right angle, slightly bent down, And this is old slipper, rubber slipper. Make a hole and put this, some weight, slightly heavy over here. Put this on your fingertip. Very nice spinner. Right? Try this. Try. Very good. This all of you should make. This is a straw, plastic straw. Tape both these ends, seal them. And then with the scissors, cut this corner. Can you see a small hole? Top right, bottom left. So diametrically opposite. Then bend this into half. And cut both these, you'll get a diamond shaped. This is a spinner and this is a fruity straw. Make a small hole here. Why the hole? If I shut this, air will come out at right angles from this hole. Put this inside it. Shut this. Very easy to make. These are all on the roadside. Not expensive. Now this is the best toy. Nails. 1 dozen nails. Now 1 dozen nails. Now, how do you put them on the head of this? Balance them on the head of this. And this is what you do. 3 nails, not magnets. No trick. Can you see 1 left, 1 right? So there are 5 left, 5 right. Equal numbers on both sides. Last nail, put it on top of the first nail. Lift both these up. See this? And gently keep it on top of this. Can you go back home and do this? Yes?
Yes.
Very easy to do it. And you can lift it. Very nice balancing toy. I've been here about, I think 3 years back, and I'm absolutely honored to be back again. I'm absolutely enthralled to see so many children from a nearby government school. Welcome, that you're able to make it. All my life I've worked for children, and it's very nice to see children. I'm a toy maker. I've been making toys for 35 years. And in the mid-70s, I was involved with the Hoshangabad science teaching program. It was a kind of a movement in the 70s to make science fun for village children where there were no labs. Professor Yashpal, one of our iconic scientists, a PhD from the MIT, came as the first teacher trainer. And this was started by Anil Sadgopal, did a PhD from Caltech, gave up his job in the TIFR and started the Hoshangabad Science. We started with 16 government schools, and it spread to 1,200 government schools in Madhya Pradesh. It went for 25 years. The most sustained science activities program in this country after independence. What I'm going to be showing you is a little glimpse of the possibilities. I did a BTech from IIT Kanpur, worked for 3 years in Tata Motors. It was called as Telco in those days. After 3 years, the first 2 years were very, very interesting. I'm a tinkerer. And the first 2 years as a graduate engineer trainee, we were doing welding and working with the shaper and the lathe machine for 2 years, which was fascinating. But once you get confirmed, life becomes very, very boring. And in 1978, I took a year off from my job, and I went to the Hoshangabad Science. And it's a small village there, and there was only a weekly haat, a weekly bazaar. And I thought, I'm going to spend 1 year over here, so might as well go to the weekly bazaar, buy one specimen of everything which is available on the roadside, because this is my lab. And the challenge is trying to do something to search possibilities with very ordinary material which is available in the village. One thing which I found was this, you can recognize this is cycle valve tube, where you actually pump it in the bicycle, use a bit of this. This is available in all our 700,000 far-flung villages. So what we did was just took the cycle tube, and if you take two matchsticks, put two matchsticks inside, you make a joint of 2 like this, and this becomes a very nice flexible joint. Children can study about angles, acute angle, noon cone, little angle, acute angle, right angle, obtuse angle, straight angle. It's like a universal coupling. You can transmit drive at any angle, and with 3, what you can do is you can loop them together, make a triangle. With 4, you make a square, a pentagon, a hexagon. You can make all these 2-dimensional shapes with these. Very, very interesting, fascinating. If you look at this hexagon, all these joints are flexible. If you pull this out, this becomes a rectangle. If you push this in, this becomes a parallelogram. But this is like an amoeba, constantly changing its outer profile. Very, very flexible. The pentagon becomes a boat-shaped. The square might look very square and prim, but you just give it a push. This becomes a rhombus. It becomes like a kite shape. But then you give a child a triangle, no matter what she does, a triangle remains a triangle. And this is the bedrock of all civil and mechanical engineering. If you wish to make any structure rigid, you've got to divide this into triangles. And children could actually feel this. All the others are very, very unstable. Now if you you can push a third matchstick. In this joint of 2, you make a hole and you push a third matchstick. And you make a joint of 3, a T-joint. And then if you take the triangle, make holes with the needle in the 3 corners and put the tripod inside. And what you make would be a very nice tetrahedron. No glue. You could make 3D structures. And once you make this, suppose you make the prism, for instance, you could put the tetrahedron on top and make a small temple or a small structure. If you took the cube, and this is a joint of 4 on the top, I'll just show you, you can make a small village house. You could make a joint of 4, a joint of 6, with 3 valve tubes, no glue at all. And then you could make an icosahedron. This is one of the 5 platonic solids. And the nice thing is only, you're talking about, if you don't have the matchbox, you can't light the home fire. And something which is available in our far-flung villages is the cycle valve tube. So we're not talking about fancy stuff. And this I was a very young engineer, 24 years old, in 1978. My first book came into 13 Indian languages. It was come into Kannada, Karnataka Raj Vigyan Parishad, 25 years back they printed this in Kannada. But this is what fascinated me, this 78, and I thought this is so much better than making trucks, right? So I've just stuck onto it. We make a lot of toys. Now this is an ordinary straw. I'm just going to press the straw, make it flat, also slightly soft, and then with the scissors, cut 2 slants. So it's like a baby crocodile's mouth, as you can see. This is a reed. I'm going to put this reed and blow out. it makes a very fascinating sound. You're not able to see how the sound is produced because the reed, which was actually vibrating, was hidden in my mouth and keep this outside. Instead of blowing out air, I'm going to suck in air. Just concentrate at this tip. What's happening? It's opening and closing at a very fast rate. It's vibrating. Children don't need to mug up for production of sound. We require vibrations. We could actually have fun with it, experience it, get ourselves enthralled. Well, what I've done is just made 2 holes. Can you see these 2 holes? 2 holes. And we're inching towards a flute. You can play a few notes. And one very nice experiment is to keep blowing at it, keep making the sound and cutting it, making it shorter and shorter. And something very nice happens. So with a small straw, you can have a lot of fun. It need not be, activity-based science need not be expensive. It's not the preserve only of the elite. In a democratic country, the fruits of science must percolate to the most oppressed, to the bottom of the pyramid. Well, there's some very nice other experiments which you can do with straws. And this is very nice. You take an ordinary straw. And what we have done is just poke a broomstick in the middle. Leave about 2 finger widths, half cut to the left, half cut to the right. Now both these arms can swivel, they can move. You bend them, what is the shape? A triangle. And then you wrap some tape around the triangle. This is what you do. Now this is a very, very nice fun experiment. I'm going to take a glass of water, and if I spin it inside, something very nice happens. Enjoy this. So it's a very nice centrifuge. You spin water. It takes 2 minutes to make this. And another very nice experiment with the straw is a spinner. Now this is about 1/3 of the straw, ordinary straw. And you tape both the ends. They are sealed with the scissors. You nip the top right corner. There's a small hole here. The bottom left corner. So diametrically opposite, you have a hole over here, top right, bottom left. Then you double the straw up. Cut both the ends and you'll get a diamond shape. This is a spinner. Ordinary fruity straw, I've just made a small hole here. Why did I make this hole? If I shut this end and I blow, then air will come out at right angles. Because this is the only opening. This goes freely inside this, shut this end, bring the spinner on top and spin. Now notice the direction of rotation. If I reverse it, you'll see that the direction of rotation will also be reversed. This also proves Newton's third law of motion, that every action is an equal and opposite reaction. Air is coming out, exiting from here, giving it a kick in the opposite direction. Exiting from here, gives it a torque in this direction. Very, very simple toy. These are very simple toys. The world of commerce is not interested in them because you can't make any money, and that's the whole purpose. That they should be for learning, not for people's greed, right? Children should be able to enjoy it. Now, this is something very, very, can you recognize this? These are strands from a woven sack, fertilizer bag, paddy bag, grain bag. In far-flung Indian villages, you're going to find a torn bag. These are 15, 20 strands from that, you just tie a knot. And the experiment is you just pull them, rub them twice. And this is static electricity. In your school textbook, I remember I used to read about the gold leaf electroscope. I've never seen this in my life. Right? This is, so how alienated our science writers are from the lives of the ordinary people. It just reflects that. And if I bring my hand is oppositely charged. Can you see this? So if a village child can bring an old sack inside the whole school can take the experiment back. It's a community experiment. Right? So this is the fun of doing science. We make lots and lots of pumps. As a matter of fact, I have a website called arvindguptatoys.com. 31 pumps. Every day I get 2-3 letters from American teachers. For the first time, sir, our kids have actually understood how pumps work. And I feel very gratified. We must do something. They are also our children. And this is it's a pump with which you can blow up a balloon. It's a real pump. You can actually pop the balloon. And we have a slogan that the best thing a child can do with a toy is to break it. Why do children break toys? Not because they're terrorists, but they're the only curious cats left. They want to know what's inside the tummy, right? They're true radicals. Radicals means going to the root, right? They're true radicals are kids because they really want to understand. And a good toy is that you should be able to pull it all apart. Now, this is an old bicycle tube based on a chance discovery. These are film cans. They're disappearing because everyone's got a digital camera. These are disappearing. But the discovery 20 years back was film cans go very snugly into an old bicycle tube. They just made for each other. And what you do is make a hole here, make a hole over here. And we have made a small, can you see this flap? If I blow from here, air can pass through. This is green light. Can I suck in air? That's what a valve is. A valve is one-way traffic. What we have made is an extremely efficient suction valve. This is my one valve. And here is a full bottle. You can see on the lid there is a hole, and there is a second valve. This is my delivery valve. And then you have a stiff straw, not a soft straw. This is my delivery pipe. So assemble the whole thing. There are no glass parts. And if you can inflate a balloon with a pump, it's a very, very high quality pump because there are no leakages anywhere. So this is absolutely an ISO certified pump, as you may call it. We make lots and lots of pumps. This is another fun pump, a very good pump. It's a toothpaste pump. Now this is an old toothpaste tube, not for throwing. So this was it's a Colgate. You need not use Colgate, all right? You just cut it over here. How many of you ever cut open an old toothpaste tube? Before throwing it, curious people always dissect. If you ever cut open an old toothpaste tube, you thought that there's no toothpaste inside, but once you cut it open, you find there's a lot of white stuff still sticking inside. That's the first discovery. This is where the lid comes in. So there are the threads. You put a balloon over here, chop the balloon. Now, if I blow from here, will the air pass through? With a loud roar. It's like a membrane vibrating. Can I suck in air? Again, in God's good world, there are many ways of making valves. This is a great valve. This is green light, and this is red light. And because it's a flexi tube, I need not put it this way. I can put it the other way around. So remember, this is green. So this is green. And we just make a small hole for the... So if I dunk it in water, what will happen? Water will go in. And the water which has gone in can't come down. So with every reciprocation, water will go, fill up the tummy, and will come out. So it's a very nice pump. Very simple pump for children, costs no money at all. All right? We have, I'll just show you another very nice pump. Forget about pumps, too many. This is a very nice hand pump. You could throw water to 15 feet. So we have 31 pumps on our website. Make all kinds of, children really get a feel, hands-on feel as to what we're talking about. Well, there are lots of, this toy has been there for almost 100 years, and this has been a darling of physicists. You take a pencil with a rubber on one end, make a few notches, V notches, 5 or 6 notches. They should be slightly deep. Take a rectangular fan, punch a hole in the middle, and put a pin inside. Now this should be loose. Can you see? It's not tight fit at all. This white rubber is like a stopper to prevent the fan from flying away. All I hold in my hand is an old ball pen refill. If I rub this, something amazing happens. This has been a darling of physicists. It's a quizzed physicist for 100 years. 6 major research papers on this. Feynman, actually, when he was 13, he wrote a paper on this. It's not trivial physics. That's why you'll never find in the NCERT textbooks, because these chaps have no answers to it. You can't put 4 probable answers and tick one. There's nothing like this over here. Absolutely amazing physics. And every child, because schools are very boring at times. I was bored to death in my school. So once you get bored of writing, you must take out your pencil and you must do this. This is what God sent all kids for, to play, right? People say this is not part of the Karnataka state curriculum. This is not part of the NCERT. Why are you teaching it? This is another question which will be flung to you. Is this part of the curriculum? Yes, part of every curriculum in the world. Right? This is the Newton's disk. He demonstrated 400 years back that white light is composed of 7 colors. Have you tried this out? No, Newton did this, so it must be correct. He's such a great man. Science is all about challenging the Newtons of the world. That's how science progresses. If you confirm, you remain a backward scientist. You will need to challenge existing theories, notions, give evidence, give solid proof. That's how you advance science. And so this is very, very nice. Here you can make this disc spin without any motor, without any battery, and have loads of fun and do. You saw this centrifugal pump just now, and this is based on there's another toy based on this. Now this is, if you were in Andhra Pradesh, this would be made out of the palmyra. It's a very old traditional toy. You can see this Acrobat, the body and the head are doubled. So there is a small crevice. You put the shoulder inside, take a needle and thread, tie a knot, pull out the needle and tie another knot. So all these hands and legs and arms are like hinges. And this is a broomstick over here. If I just swivel this, you can see this. Fascinating toy. If you spin something, it tends to fly out. And if I do it with both hands, like a flying man. Something which costs no money. You need a needle and a thread, probably available in every house. Right? Fascinating toy. We have, this is an excising man. Again, a broomstick, a bit of this fruity straw, and an old card sheet. Very nice. Fascinating toy. Right? Beautiful mechanism. It's like excising man. Well, we make lots and lots of toys with, this is of course the simple motor. Irrespective of the curriculum, all children in class 9, 10th study in electricity about the electric motor. Modern life would come to a standstill without the motor. In a typical middle class house, we use a motor at 10 places. It's in the mixie, it's in the fan, it's in the cooler, it's in the washing machine, it's in the air conditioner. Now this is one battery, 1.5 volt ordinary battery, new battery. 2 safety pins, old cycle tube, which keeps both of them snug to the plus and the minus of the battery, 1.5 volts across both these. This is a ferrite magnet, very simple. It's a very weak magnet, you don't need very strong magnets. 1 meter of insulated copper wire. You make the coil. Takes 10 minutes to make a motor like this. If you have the battery, it costs 5 rupees. This is not a rich man's game. Every child must understand how a motor works. It's essential. This is people science. You don't need to be a PhD to understand how a motor works. This is people's understanding of science, that in a scientific society, rational societies are always better than blind societies. Every child must learn this. We made this in 1990, about 25 years back. I think literally millions of kids have learned how to make this motor. And as I said, if you have the battery, 5 rupees for making this motor. That's all it costs. Cycle tube is free. These are 50 paisa each. These magnets are 50 paisa each, 1 rupee for the, less than 5 rupees to make. Well, this is even... This is recent, about 6-7 years back. These are very strong magnets. These are called as neodymium magnets. If you look at the periodic table, there is an element called as Nb. These are rare earths, and China has the largest deposits of rare earths in the world, and they're sitting put on it. So all these magnets come from China. Even these ferrite magnets come from China. They've built up such large capacities that no one in the world can compete with them today. Now, these are so strong that 2 of them, you can't even separate them. This is an old plastic barrel of a syringe, old injection. Medical technology throws away so much of junk all the time. The higher the technology, the more the junk it creates. Now these two go into the barrel, they're free, they can move. Here is a little stopper. Now you take thin insulated copper wire, which you use for motor rewinding, 1,000 turns of it. Both the ends you scrape the insulation and you attach a LED, that's it. From start to end, it takes half an hour to make it. Now, if I'm going to shake the magnets, so there'd be a moving magnetic field inside a coil. And this is what happens. We are producing electricity. We made a generator. This is how electricity the world over is produced. Now, you might have read Faraday's laws of induction, but once we actually make it, it does something to you. That, well, it empowers you truly. That I can make electricity, I can light a LED today. So these laws are quite true. All right? Very nice. Today I light a LED, tomorrow I light up my village. Where I come from, UP, there are 10 hours of power cuts. Imagine a girl in a UP village school, 7th, 8th class girl, makes a generator. She says, oh, today I'm lighting up LED, tomorrow I'll light up my village. It's truly empowering. This is empowering education. Wonderful. We have a multi-generator on our website. It's in Marathi. 4,040,000 lakh viewers of our video. On the internet, today we have 6,700 videos in 18 languages. We work out of a room which is 400 square feet, half this room, but produce great stuff. 45 million viewers of our videos in 18 languages. We have 200 of our videos in Chinese, by the way. China is threatening the world, flexing its muscles in the South China Sea. Someone who wrote to me, despite, no one knows the reality of China. There is a bamboo curtain that despite all this hype about China, it's actually quite a poor country. The state wants you to see what they want you to see, right? You don't get to see the other side of China. But she said this would be extremely nice to dub these videos into Chinese. So they dubbed 200 of our videos. We have 300 of our videos in Spanish. Spoken in 26 countries. And so wherever we find, Kannada, we have 900 videos in Kannada, dubbed by one single man. His name is Prabhakar Nanavati. He just happened, Maharashtra and Karnataka are both fighting over Belgaum. He was born in Belgaum. And he says that Marathi and Kannada are both my mother tongues, with pride. So this man used to work with Dr. Naren Dabolkar as part of the Andhshraddha movement. So he has dubbed 900 of our videos, creating absolutely a new genre of science films in Kannada. This is something which won us some accolades, and this is a levitating pencil. You saw these little magnets over here? Now these are ring magnets, and 2 of them can go into a pencil very easily. We have put 4 in this rubber, 2 in this pencil. Now the front ones attract. So they must be opposite poles. One is north, the other is south. That's why they attract. The rare ones are same poles. If this is north, these 2 are also north, so they're repelling. If this is south, these 2 are also south. Same poles, so they repel, and they lift the pencil up. And because they lift the pencil up, the lower end of the pencil is lifted, and the fronts are attracting it. So if on my finger, you can see I'm just balancing can you see this pencil is spinning on my finger? And what I do is, I take this is an old CD, from a DVD CD. You cut it and you put it over here. It's like a very smooth piece of glass. If I put this here, here is a pencil which spins, which levitates, and it spins. Many parts of the world, there are maglev trains. If you go to Beijing, if you go to China, Beijing, the international airport is 70 kilometers away from the old city. You take a maglev in 10 minutes, you've done 70 kilometers, you're inside the city. It's a reality in many parts of the world. Our kids can get a glimpse of what a maglev train is. Oh, this is a very fascinating toy. Now you must, Delhi is very much in the news for all the wrong reasons. It always is for the wrong reasons. It's one of the most polluted cities in the world. It is trespassed. Beijing is the most polluted city. But 20 years back, when we didn't have the CNG buses, only diesel, the public transport was on diesel. At that time also, Delhi was awful to live in. I lived in Delhi for 14 years. 20% of the children in Delhi suffered from asthma. And at that time, we said that we must make some toys for kids who suffer. And this is, you just take a pencil, make a small hole in a straw. And this is a loop of wool. That's it. Wool has a lot of fibers. And if I blow from one end, all the fibers are going to be pushed, and this whole loop will go. Something which costs 25 paisa for a child to make. If you give it to a child, the only thing the child can do is to blow at it, and it's like an exercise for the lungs. Very, very good toy. Now this is a very, very fascinating toy. This is, there is a book called The Joy of Making Indian Toys, written by Sudarshan Khanna. He worked at the National Institute of Design for 35 years, and he did this book for the National Book Trust. It's a very beautiful book. This toy is right from Sudarshan's book. What you do is you take a thread reel, this ordinary cardboard thread reel. Here is a string, here is a length of string, and you can see two rubber bands. One is silver, the other is black. To distinguish them, you double the thread and weave it through this. Very simple toy to make, but very intriguing. Now I'm just going to hang it on my index finger. I pull out one, the black one, and the silver one takes it up. Now I pull the silver one down, and the black one is coming from below. It's going to hijack the lift and take it up. Once again, I pull the black one down. The silver one is coming from below. It hijacks. It's a very fascinating toy. Well, there are lots of paper toys which we make, and this is the simplest paper toy which you can make, a flying toy. Take a strip of paper like this, and I'm going to make a half cut. Leave about a centimeter. Can you see this half cut? Take it up. This cut is in the top. Make another half cut. So there is a half cut below and a half cut above. Just going to interlock both these half cuts. And what do I make? What does the shape look like? A fish. A fish. And a fish is supposed to swim in water, but this is a very special kind of a fish. It's a flying fish. If I just chuck it up in the air, can you see this? All our newspapers, magazines, we cut into little squares, and children can spend a lifetime on a square. This is, if you just fold the opposite corners, what do you make? You make a big triangle. If you fold this again, what do you make? You make a small triangle. And this is like the letter V, V for van, V for victory. This also looks like the 2 ears of an animal. 2 ears of an animal. And I'm just going to just tear them and make 2 long and slightly rounded ears. Fold this to the front and fold this to the back. And this becomes like a rabbit. Mr. Rabbit, rabbit's mouth, rabbit's long ears, front legs. And you hold this the legs just below the body, not on the body. Grab the tail and move the tail forwards and backwards. And it's a 10-second toy. Children have made it for literally decades. Children have been making this toy. Very unlike the He-Man, Skullman, the Barbies, very sexist, very violent toys. The earth is unable to sustain these idiotic toys. But advertisement, ensures that they're there in every house. But once all these toys are buried, kids would still be making a toy like that. We may not be there on earth. Again, if you take a square piece of paper, there's no glue, no scissors, and this is documented history. Children have been making this flapping bird for 300 years. Just a square piece of paper, no glue, no scissors, your 10 little fingers, and you make this very beautiful bird. Origami, Japanese art of paper folding, it's dovetailed into the religious rites. Come Holi, Diwali, we're going to eat sweets, burn crackers. In Japan, they would eat rice cakes, and then the whole family will sit down and fold paper. And because they have dovetailed into their religious rites, it has sustained itself for 300 years. Very amazing thing. And what we did was, took the same bird, and we put cut off the tail and put a fan. So it's a fan tail. There is a refill over here, ball pen refill, and there is that's the bush or the bearing, and there is a pin rotating inside this. And this is like you make a small helicopter which spins. And there's a thread. If I just spin this around, it's a fan-tailed bird. It costs no money at all to make a thing like that. No matter how much money you have, none of these superstores can you buy it. You can only buy stupid toys. Clever toys are always made. Clever people have always made their own toys. So this is it. Poor children can afford it. Don't throw away all ball pen refills. That's it. A bit of glue, a pen, and that's it. This is a very nice, can you see this? It's just like the opening and closing of the wings of a butterfly. You can see this. Very, very simple toy. But this is with a quarter. All these newspapers come with all kinds of rubbish mail, and you always fold them into making. So this is it. Now this is like a clapper. You can see a depression. It's like the paper spring end. It's a very nice toy like that. Right? No glue, nothing. Paper clapper. You make a very nice peacock with the paper. This is something very interesting. You take a paper and a doubled paper like this, and this with a pencil, you make it black. It's like a poor man's carbon paper, all right? And then you draw this picture on the top. And because of the carbon paper, you will get exactly below the same face, the same two eye sockets. Now you can see the eyelids are to the left over here. They're to the left, eyeballs to the left. In this, the eyeballs are to the right. So we make small changes. Over here, the boy is smiling. Over here, there is no smile. And this you curl like this. This becomes it's like a paper spring. And I'm just going to put it on the board. Look at this. Can you see something? It's like a very simple animation. The eyes would be moving from left to the right, left to right. This is the first step in animation, which every child can enjoy very much. Now, this is something very, very special. I worked in the Pune University in Ayuka for 11 years. And inside the Pune University is a huge campus, 411 acres. It was the British governor's summer residence. And inside the university, there is only one school. It's called as the Vidyapeeth Shala, run by the Karve Shikshan Sanstha. It's like a municipal school, very poor children, 2,500 children. None of the faculty in Ayuka ever send their kids to that school. They send them to larger enclaves, the Delhi Public School, which is 35 kilometers away. All the faculty will send the kids there. And so the school goes down and down because the privileged find gated communities for themselves, nothing to do with ordinary people. We said it was our promise that we would work with municipal school children because they need us the most. So for 8 years, we ran a science club in this school. Because no other reason, it's a neighborhood school. And there was a girl there, her name is Durga Jetty, lives in a jhopalpatti in a slum. Father is a drunkard, bashes up the mother every day. Durga is witness to it. Durga has to wash dishes in 4 houses before she actually comes to school. This is what Durga made as part of her school project. Today it's famous the world over as Durga's turbine. What she did was took a small bottle, cut out the bottom. So it's like a tube. You can see it's like a tube. This is the lid. In the lid you make a hole, not in the center, off center, slightly away from the center. Then you take 2 safety pins and tape them on the rim. So they are like 2 pillars with 2 eyelets. Put a needle over here and put a turbine. Here is a fan or a turbine. Now I'm going to screw on the lid. Now if I'm going to just put this in water, what will happen? Water will enter the bottle. Some of the air will be expelled, and this air is going to drive the turbine. See this. She did, in a high school, she stood second in her school, 94% marks. Very bright girl. And then the Times of India, Pune edition, gave Durga's photograph and this model that helped this girl. Here's a very, very gifted girl. And they're very generous people in society. 517 checks poured in for Durga. In a glittering function, Professor Mashelkar, who himself, he was the Director General of the CSIR for 10 years, led the NCL in Pune for many, many years. fellow of the Royal Society, came from a very humble background. His mother was a housemaid. And so a very, very appropriate person, he gave Durga an award of 7 lakh rupees. This is the potential of every girl in science in this country. Right? Today happens to be the Women's Day, and we must pay tribute to our women and our girls. There are many, many schools which are. I lived in Delhi for 14 years, and the principal of the Sardar Patel Vidyalaya was a very, very, very strong feminist. There were 2,000 students in the Sardar Patel Vidyalaya, and no fancy school. Please, in the political class knows what a good school is. Where do Smriti Irani's 2 sons go? They go to Sardar Patel Vidyalaya. They don't go to the Global Indus School or any funny school. They go to Sardar Patel. Where do Amartya Sen's granddaughter? She studies there. Where did Manmohan Singh's 2 grandsons go? They went to Sardar Patel Vidyalaya. So her name was Vibha Parth Sarthi, and G. Parth Sarthi's daughter-in-law, very strong feminist. She ensured that every boy in the school learned how to cook. They said, you eat, so better learn how to cook. Right? Simple as that. Every boy had to learn how to do rangoli, right? Which is supposed to be a girlie's art. And the girls did everything which the boys did. And because of this positive affirmation, I can tell you, in my daughter's class, they were amongst the first 10, there was not a boy. NID National Institute of Design takes 60 students every year. Three girl students went to NID that year. 2 went to IIT Delhi. My daughter went for medicine. So there was not a boy amongst the first, and give them a chance. We've always treated them as all these soft subjects like sociology and literature, arts, these are for the girls, and the hard, maths and statistics are for the boys, right? We must break this. Given a chance, girls are much more focused, they're much more hardworking. Give them a chance. And this is the message for Women's Day. And what else? Well, this is some other very nice, fascinating paper toys. This is something called as a Hexaflexagon, designed by a mathematician at Harvard in 1928. This has been documented by a person called as Martin Gardner. Martin Gardner used to collate a maths puzzle for the Scientific American for 25 years, and they are out into 7 books. Maths puzzles, more maths puzzles, further maths puzzles, mathematical garden, mathematical circus, mathematical carnival. One book is a chapter, whole history of the flexagons. Fascinating. Arthur Stone, and here's a piece of paper which you could keep rotating. You see what pictures do you see right now? You see butterflies, frogs, snakes, eagles, butterflies, frogs, snakes, eagles. 4 pictures coming in a sequence one after the other. And you could weave a story that insects are eaten by the frogs, frogs are eaten by the snakes, snakes are eaten by the eagles. It's like a little food chain. And science is all about stories and cycles and chains. This is the water cycle. We know that the sun is the source of all the heat. All the energy on earth comes from the sun. That's why in all religions the sun is worshipped, revered. It's the sun's heat which leads to evaporation of water, and we get clouds. It's the clouds which bring about rainfall, precipitation. Once it rains, all the reservoirs are replete, the wells, the lakes are full of water, and the sun is once again back, evaporating water, making clouds, bringing rain. That's what the rain cycle is. And science is all about cycles and chains and sequences. And if you had an A4 size paper like this, printed on one side, plain on the other, no glue, no scissors for this, a scale and a pencil, and in 3 minutes you could fold this. 3 minutes you could fold this. Fascinating, absolutely. This is, poor municipal school children could make this world-class model. It costs no, and what you could use it is limited by your imagination. This is not just limited to the study of science. If you're a history teacher, history is all about a timeline. Suppose you look at the Mughal period. Who was the first Mughal emperor who came to India? Write the name, draw the picture, write the dates. Who's the one who ascended the throne next? Who's the one who became emperor next? And you can make history much more interesting. You could repeat this for the Maratha period. So any science, any history teacher could make history alive with a flexagon like this. If you use a small piece of paper, you can make a smaller flexagon. Very small, very nice. There's also this 14-page Unending book. This starts like this, 1, 2, 3, 4. Now you require 2 squares like this size, 2 squares, and a bit of a glue. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's the last page, and you start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fascinating model. Now, all children have some story. They love some stories which they can hear 50 times without getting bored. They know it upside down, inside out, but they're never bored of hearing it again and again. And they can divide this into 14 steps and draw pictures. And every child has a very dynamic, moving, rotating picture book. It's a 2-minute picture book. Well, we use a lot of these. There's a book which I did 20 years back. It's called as Little Toys. It's by the National Book Trust. And at that time, 20 years back, the Tetra packs had just entered in the Indian system. And this is a kind of fruity packet. And you could do some very nice things. I said that don't bring fruity because it's if you've seen the inside of a fruity packet, it's terrible from the point of view of the environment. Because what you see is food-grade plastic. The silver part is aluminum foil, 3 layers of plastic, 1 layer of aluminum, 1 layer of card sheet. They all fuse together. It's very energy intensive to separate the plastic and the aluminum and the card sheet. So it's going to be lying in a landfill for the next several hundred years. So we said that, well, pick up a Tetra pack from the roadside and I'll show you how to make 30 toys with this. This is the book. It's called as Little Toys. And now this is a fruity packet. How much fruity does a packet contain? How many milliliters in this fruity packet? How much? Speak here, doesn't matter. 1 liter, half a liter, 250 liters, 200 milliliters. This one is 200 milliliters. It's written over here. And if you measure the length, the width, and the height, and you multiply, you will get the volume. This is all mentioned over here. It's 200 ml. Now we just cut it into half. How much water would this hold? This is 200. This is half. How much is this? 100. And it's a very nice thing. And what I'm going to do is, it's a very nice. Fill this with water. How much water here? 100 ml. How much water have I drunk? 100 milliliters. I take my cup and put in my pocket. All of you must carry this in your pocket. It's very good science. Right? Okay. 100 ml, 200 ml, 3. It's a very clean cup. All right. Hey, keep it in your pocket. And very nice science. You could also make a very nice. Now, this is again the Tetra pack. This is like this. Tetra pack is like this. And you make a curve over here, make a cut here. And this makes for a very nice. Can you see what is this? It's a very nice funnel. See, you can pour water. Very nice funnel. If you want to pour out oil inside the house, it's a very nice funnel. And the nice thing about this funnel is that you can flatten it and put in your pocket. No plastic funnel you can put in your pocket. It's a very useful funnel to make. I also want to show you this very, very beautiful. This is a bird. It's a bird whistle. No one makes it. They make it in clay, which is very expensive. Someone very kind. He made a few thousand for us in Pune. Now there is a whistle over here, and there's like a water tank. If I blow, not much fun, but I'm going to fill this with water. Yes, and if I blow from here, it makes a very nice bird calls. Very magical. Something costs 3-4 rupees. The Amazons and the Flipkarts of the world, no one is interested in a bird like that. Right? They're all just interested in minting money and nothing else. But fascinating for children. And this is not rocket science. This is not like gravitational waves. We can do this. Just 2 pieces stuck together, that's it. So I'll show you another. This is like the hand pump. This is one more, like the hand pump. You all have operated the hand pump, water comes out. Now this is This is a film roll bottle. I've made a hole in the base. Then take a 1 rupee coin and put this inside this. So if I blow from here, will the air pass through? No, because the coin is wet. It is very heavy, so no air can pass. Can I suck in? I've got to be very careful, otherwise the coin will go in my tummy. All right, I've got to be careful. But it is responding. Okay, so it's like a valve. This is green and this is red. Water can come up but can't go down. Now what is this? Can you recognize? This is this bottle cap. Bottle cap. And one discovery was this bottle cap goes very nicely into this. So this is a cylinder, this is a very nice piston. Much to discover. And what we did was, now there is a hole over here. Can you see the second valve? Can you see the small valve opening and closing? This is my delivery valve. And this is the, to move the piston. And there is a small hole. Can you see the small hole? This is for the water to come out. So all the elements, this is a cylinder, this is a piston, suction valve, delivery valve, and this is a up and down. Now I just put this over here. And this, where should the hole? Hole is right over here. I put this in this bottle. Very nice hand pump for children. This is a very nice toy. All the boys are going to like it very much. I like it very much too. This is in Sudarshan's book, The Joy of Making Indian Toys. What is this? It's a flick knife. A very, very dangerous toy to make. All the girls must carry it, because if someone frightens you, you can always say like this. These are made from 2 ice cream sticks. It's a flick knife, right? And you press a button and press button. Now, this is the children of this school, Durga school, Vidyapit Shala. They made this toy. And what they did was, they made this levitating pencil in the center. And so they had some magnets. Next day they showed us this. Look at this. Can you see this is vibrating? Okay. So what they did was, they took a cup like this, ordinary paper cup. We have decorated it with red and green tape. There is a hole in the base, and you take 2 magnets, one below, the other on the top, and they're sticking to each other. Good. And now, if you just put this in this is a cycle spoke, bicycle spoke. 6 class children have designed this toy. This is original design. There is no reference in literature to a toy. Children can create their own knowledge. Give them a chance, give them a space. Don't ask them to mug up the state textbooks. And they're very capable of doing something very, very original, right? Wonderful toy. What else? Did I show you this? There's one with the... What do you have? Now this is again from Sudarshan's book. This is a very nice toy. You take a broomstick, a long one and a short one, and this is at an angle and you tie them very tightly. And for some weight, you take a piece of old slipper and put it inside. So there is heavy slightly. You can take a baby coconut itself and put it in and spin it like this, like the Sudarshan chakra, right? Spinning around and around on your finger. And this is one boy, class 3. He made this. A variation of this. You can see structure is the same. But third class student here to make, now the government is talking about, it's a progressive government. It talks about progressive educational ideology. So learning by doing, every child has to make a project. So this boy thought he had made a satellite. You can see these two, these are solar panels. Satellites are solar panels because you should generate your own electricity up there in space for all the controls. and the satellite is spinning around Earth. So for the child, this was the satellite. Do you like this model? Yes, it's like a satellite. For child, very good one. We use a lot of Tetra packs for many, many things. One is this, you just saw the, now this is a 1 liter fruit juice box, Tetra pack. People just throw it away. And this is a very nice purse you can make. You can, if you have some money, you can put some coins, you can put some rupees over here, waterproof, and there is Velcro over here. You put Velcro and put the purse in your pocket. A very nice purse. And how do you make it? This is how you make this purse. Very simple. This is a small model, but the big one is like that. You take a fruity box, cut one flap completely, push this inside. So they give it a kind of a depth. Then double this up. And these two inner walls you staple. Inner walls you staple or glue together. And this becomes a flap. So it's a small purse and this is a big purse. Same way how to make it. A very good purse. Right? So pick up Tetra packs from the roadside. This material is lying there all the time and you can make a very nice purse. Now this is again made from a Tetra pack from this network. And this is a cube, and green all over. This is green all over. And it's an inside-outside cube, and now it's silver all over. Silver all over. Again, you can make it green, you can make it silver. Very nice material because there are 3 layers of plastic, 1 layer of aluminum. You can flex it 100 times. Ideal material for making toys like that. It costs no money and very good. You can also make this, you saw this icosahedron earlier. You can just make a network of 20 triangles and make it with a Tetra pack. Very easy, just need a compass. You just mark them, score them, bend them, and make a icosahedron. Same model. This matchsticks this with a Tetra pack. Now this is a very, very nice, fun toy. You can see that there are some this is the calendar. There is a book on my website by P.K. Srinivasan. Well, there is a lot of maths in a calendar. He wrote a book 30 years back called as Number Fun with a Calendar. Any month, any year. Look at these numbers. 4 plus 12 is 16. 5 plus 11 is 16. 7 plus 13 is 20. 6 plus 14 is 20. Any cross numbers, 21 plus 29 is 50. 22 plus 28 is 50. Cross numbers. 8 plus 16, 24. 9 plus 15, 24. Cross numbers. Did you ever notice this? We can take a 3 by 3, 9 numbers. 2 plus 18 is 20, double of 10. 4 plus 16 is 20, double of 10. 3 plus 17 is 20, double of 10. 9 plus 11 is 20, double of 10. What is the sum of all these 9 numbers? The average is 10 and they are only 9, so it's 90. Very beautiful. How do you add up all these numbers? This is 4 and this is 7 days in a week, 28s. 4 into 7 is 28 numbers. Look at this, 5 plus 25. No, we'll come over here. 3 plus, all these numbers, 28 numbers. 3 plus 30 is 33. 24 plus 9 is 33. 4 plus 29 is 33. 25 plus 8 is 33. 6 plus 27 is 33. 13 plus 20 is 33. How many pairs of 33? 14 pairs, 28 numbers. 33 into 14 is the answer. So he wrote a beautiful book called as Number Fun with a Calendar. It's on my website. It's also in Kannada, by the way. Nav Karnataka has printed this book in Kannada. So there's so much maths all around us. No one ever tells us that arithmetic progressions are right there. If you have a Friday on the 1st, the second Friday will come on the 8th, the third will come on the 15th, this is arithmetic progression. No textbook ever talks about that APs are in the calendar. There's something to be mugged up and you spit it out in the exam. A fascinating way of learning about the calendar. this is a it's a ring with 4 nuts, cycle nuts. 4 nuts, steel ring. We've just put a welding joint over here. Now look at this. If I just flick all these 4, they keep going on like that. No one makes this toy in this country. This is a country of 1.2. This is Make in India. This is a country of entrepreneurs. See, 200 years of British rule has left behind a colonized mind. The worst thing with India is a colonized mind, right? This is simple stuff. Now you have got 3 going. And as long as you keep spinning it, they keep rotating. And suppose you take this paper, this is A4 size paper, and this is half this paper, A4 size. With half this paper, you can make a skeleton, a scale model of a skeleton. Just half this paper. You make the skull, you make the rib cage, you make the pelvis, fibia, tibia. There are 200 odd bones in the human body, and this is excellent exercise for a child in class 3 or class 4. The poorest children could afford it. And then this being the Women's Day, you must ask, is it a skeleton of a man or a woman? We have no clue about it. Is it a skeleton of a Hindu or a Muslim or a Christian or a Jain? We have no clue about it. The Genome Project only demonstrated our oneness of all human beings. 99.999% of the human genes are the same. Why the hell do people kill each other in the name of religion, in the name of language? Very nice model to take off, not just on science, but many deeper social malices. Very, very nice. Well, we make lots and lots. I must like to show you, this is something really nice. This is a slate which is meant for blind children, children who can't see. This is Velcro. Do you know what Velcro is? Velcro, 2 strips in bags, you put Velcro. 2 strips stick to each other in bags, in shoes. Some people might be having Velcro in their shoes. So this is the Velcro, not the loop part, only the hooks. So there are millions of nylon hooks. This is my slate. And this is my drawing pen. And this drawing pen is like a fishing line. See, this is a cycle spoke. You bend a cycle spoke, make a crank, put a rubber, remove some rubber so that you can put some wool in this. And you put this inside this. And if you crank the handle, all the wool is getting wrapped up. Can you see? And wool has a lot of fibers. And now blind child can't see with the eyes. Have you seen blind children? They read with their fingers. Braille books. Now a blind child can just draw. And once they have drawn, they can feel it with their fingers. How many blind children in this country? Maximum number of blind, 13 million. Imagine the population of Mumbai. Every man, woman, child can't see. That's the extent of blindness in this country. Very amazing thing. Every blind school uses this slate. It's called as a touching slate because you've got to touch to feel it. Very nice slate. I must also show you. This is, you can just see that, I just showed them that. A dozen nails, you could just arrange them in a pattern like this. There are no magnets at all. How do you balance a dozen nails on the head of one? It becomes a beautiful balancing toy. The only thing you need to buy is nails, which are available in every hardware store. Nothing. Very, very beautiful balancing toy. Well, in the end, I might just tell you one very nice story. And this is, with newspapers, we make lots and lots of caps. Half a newspaper, and you make, this is the Nehru cap or the Gandhi cap. You make a very nice cap like this. With another half a newspaper, you make a cricket cap. Very nice cricket cap. Cricket cap. A very nice cricket cap you make. And And this is the story. It's called as the captain's hat story. And this is the story of a seagoing captain. Now, this ship has a lot of passengers, and they are all going for a long voyage on the sea. And the first 1 or 2 days, all the passengers enjoy the journey very much because they are going on to the sea. But after 2-3 days, all they see is the vast blue ocean, not a patch of land, not a tree. All of them become bored. They become seasick. That's the term. Now, Captain Topi Shankar was a very clever man. He invited all the passengers on deck, and he said that you sing and dance the whole day, enjoy the journey, and I'll provide you with good food and drinks. And Topi Shankar had a suitcase full of different caps, and he would join the party every day. First day, he would wear a huge umbrella-like cap. It protects the captain from the scorching sun, from the rain. So it's a huge umbrella cap, cap number 1. At night, when all the passengers would go to sleep, the captain would take the same cap and give it 2 more folds. And the second day, he would be wearing a new cap. You know who wears a cap like this? The firemen, the fire brigade people who put off fires. They've got to wear a special designer cap because they work under very hazardous circumstances. They'll go into a burning house. If some rubble falls, it must protect the spinal cord. So they really wear a designer cap. Cap number 2 is a fireman's cap. Second night, he would fold the same cap. And this is a third cap. This is a shikari cap. It's the adventurous cap, cap number 3. And the third night, well, 2 more folds. Now, this is, if you have ever seen any of our Bollywood films, Bombay films, you like, even Kannada films, you must. But the policeman always wears in Bombay a cap like that. And this is called as a Pandu cap. It is very, very famous, right? So 4 caps. Who remembers the first cap? First, the huge umbrella cap. Second is the fireman's cap. Third is the shikari cap. And fourth is the Pandu cap. And we must not forget that Topi Shankar, he was a captain of a ship. So that is the ship. So everyone was enjoying the journey very much. They were singing and dancing. And suddenly there's a storm on the sea. There are black clouds. It starts to rain. There's lightning. And the sea is on fire. Huge waves. And what can a ship do? It is rocking and pitching with the waves. And then a huge wave comes and slaps the back of the ship and knocks it down. Are the passengers happy? No, they're terrified that our ship is broken into 2 pieces and soon it will sink. And then another huge wave comes and slaps the front of the ship and knocks it down. Now the ship is broken to pieces, and what is the ship doing? It is sinking. And this triangular portion of the ship is called as a bridge. And then a third huge wave comes and slaps the bridge and knocks it down. Now the ship is broken to pieces. The ship is sunk to the bottom of the sea. The captain has lost all his caps. His suitcase is also sunk. So the captain has lost it all. All that remains is a life jacket. Now this is like a life jacket. So thank you very much for coming for this lecture. I hope you enjoyed it. It's over here, there are some leaves, but there's no color over here right now, or just the outline, and they're not much fun. But if I just pull this around, you can see this all color. And if I just push this inside, all the color is gone. It's like a very magic card. And how do you make it? It's just this, you can see this. I'll open this and you can see this is a transparency on top. The inside one is colored, okay? And then you put this, then you make with a marker pen, you make the outline on the top. And if you put this strip inside, you just see the outline, right? If you pull it out, then you see the whole picture. Very, very magical. Again, this is it's a bird, it's a woodpecker, and this is a spring. By just tying some things on, you make a very nice spring. And becomes like a woodpecker. Oh. This is just, take some wire, about 2 feet of wire, wind it on a circular pencil, you make a small spring, remove the spring, pull this out, so this will become like a spiral. And these are pieces of cut straw. I would like to just gift, there is a DVD which we made about 8 years back, it's called the Learner's Library. Siva has a copy of it. There are 800 books in this, 30 of my books, plus amazing books on education, 7,000 photographs, and 200 videos. And this is free share. Anyone of you are interested, ask Siva to make you a copy. And this is for the teachers of the government school. Madam, thank you very much for coming. A small gift from me.